Today's learning target is I can compare and order numbers written in scientific notation. The first thing that we want to talk about today is what is scientific notation. So when we have numbers that don't contain exponents, they're written in what we call standard form. So these are all examples of standard form. However, when we deal with either very large numbers, like this one, or very small numbers, like this one, we often use what's called scientific notation. It's not uncommon in science to come across numbers like this when you're dealing with something that's microscopic and very small. This might be the measurement of something, or something really large. You know, when you're dealing with planets, you might be dealing with a really large number. And that's when we'll use scientific notation. These are all examples of numbers that are written in scientific notation. Now, if you notice, every one of these has a power of 10. So when we write in scientific notation, we're going to use a power of 10, and we're going to multiply that by a factor or by a number. But the deal with the number is it has to be less than 10 and greater than 1. So you'll notice every one of these is 1 or higher but less than 10. Okay, so this one, it's less than 10, it's less than 10, less than 10, less than 10, and this one is right at 1. So remember, when using scientific notation, the factor that you use in the scientific notation must be less than 10, and it has to be at least 1. So in this case, this problem right here, this is not written in scientific notation because the factor has to be at least 1 whole. So that is not 1. Okay, same with this one here. It has to be less than 10, the factor that you use. This one is greater than 10. So this would not be correctly written in scientific notation. Let's take a look at how we would express each of these numbers in standard form. So if I'm given this scientific notation and I want to write it in standard form, now I know that 10 to the third power is really just 10 times 10 times 10. And I know that I can use mental math to multiply by tens very easily by moving the decimal to the right. So when I have 2, and I'm going to times it by 10 to the third power, okay, I know 2 is really the same as 2.0. I'm going to move the decimal to the right 1 time for every 10 that I multiply it by. So 2 times 10 would give me 20, times another 10 would give me another 0, and another 0. So I fill in those zeros, and 2 times 10 to the third power would be 2,000. Now in this next one, 6 8/10 times 10 to the 5th power, so I know I'm multiplying 6 8/10 by 5 tens. So if I'm multiplying by 5 tens, I know I'm going to move this decimal 5 places to the right. Okay, so when I do that, I just start off, I go 6.8 and I move the decimal 1, 2, 3, 4, 5. I'm going to place my zeros in for each of those placeholders, and so I would have 68 and 4 zeros, so now I place in my commas and it shows me 680,000.
In this last one here, we're going to take 3 27/100 and times it by 10 to the negative 4th power. Now, I know another way to write 10 to the negative 4th power is 1 over 10 to the 4th power. So we could write that problem, rewrite it this way: 3.27 over 1 times 1 over 10 to the 4th power, which is this. And when I solve that, here's what I get: 3.27 over or divided by 4 tens. So we know when we divide by 10, we're going to move the decimal place 1 place to the left for each 10 that we divide by. So I'm dividing by 10. I'm going to have to move this decimal 4 places to the left. So moving it 4 places to the left means 1, 2, 3, 4. Put my decimal in there, put zeros in for my placeholders. And my final answer is right here.
So to write numbers in scientific notation, remember we need 2 things. We're going to multiply a power of 10 and a number that is less than 10 but at least 1.
So when I look at this number, I see I have 4. So it's greater than 1, less than 10. So I'm going to put 4 in here. Now my decimal point in this number is right here. So I have to figure out how many times I'm going to have to times 4 by 10 to get this decimal to here. So 4 would be right here. The decimal would, if I looked at just 4, would be right after the 4. And I would times it by 10 once, twice, 3, 4, 5, 6 times. So if I have 10 sixes that I'm timesing it by, I know I write that as 10 to the 6th power. So that's how I would write that in scientific notation. Let's take a look at this one over here. So 5800. Now I want to write that in scientific notation. So I notice here 58 are my digits that I'm dealing with, but I have to have that between 1 and less than 9. So if I did 5.8, that meets that requirement. Now that means I want to figure out 5.8, how many times I have to times that by 10 in order to get the decimal to the end here. It'd be once, twice, 3 times. So that would be times 10 to the 3rd power. In this last one down here, okay, I see that my digits that I'm going to be working with are 72. So we know we could write that 7.2 to make it less than 10 but greater than 1. And to do that now, I would start with my decimal right there, and I have to move it to the left once, twice. So to move it to the left twice, I know that that's going to be 10 to the negative 2nd power. In this last problem here, I'm asked to order these numbers in order from least to greatest. So step number 1 is going to be to get them all into standard form, just like this one is right here. So let's start with this one right here. 3.4 times 10 to the 2nd power. Now I know that means I'm timesing this 3.4 times 10 twice. So that means I'm going to move my decimal to the right once, twice. So when I do that, that's going to give me 340. Okay, now I can look at this next one here. 3.5 times 10 to the 2nd power. It moves it twice, so once, twice. That becomes 350. Okay, now on this third one, 3.7 times 10 to the negative 2nd power. I know that means I'm dividing by 10 twice, so I'm moving my decimal to the left 2 times, once, twice. So that becomes 37 thousandths, written like this, and this one's already in standard form at 400. And once I get them into standard form, it's easy to see that from least to greatest, here's how it would be. And notice I separate them with semicolons so that we don't get them confused with actual numbers with just using a comma.